All right. So let's do the following. Let's take the number 2.53 times 10 to the ninth, and we're going to divide it by 2.7 times 10 to the negative 2. Okay? So let's do that. So the first thing we're going to do is take our what do they call those numbers? The ones that are in the front? Coefficients. If you're old timey like me, mantissa, but I like coefficient better. So we're going to take these and we're going to multiply, um, or divide rather. 2.53 divided by 2.7. It's a long one, isn't it? 0. What did you say? 9370. Okay. 0. It's repeating, I guess. 370, 370, 370. No? Okay. 937. Let's just do that. 0.937. Stop it there. Okay. We have to fix this. But while we're at it, let's go ahead and do this. 10 to the 9 divided by 10 to the negative 2. Because we have to divide these. Which means take your exponents. Yeah. 10 to the 9 take away 9 minus. I always consider the fraction bar my instructions to subtract. And what am I going to subtract? Negative 2. 11. 11. Yeah. Do a little keep change opposite. Or keep change flip. Keep change flip. It's 9 plus 2. So we get 10 to the 11. Okay. And here we're going to move this over. Make this number actually bigger. So we have to compensate here. This 11 becomes a 10. You're making this bigger, so you have to make the power of 10 smaller by 1, however many places. So final answer, 9.37 times 10 to the 10th. Are we okay with that? Any questions? Okay. So let's apply that.
Wait, about why do we need to move the decimal?
Oh, because it has to be in scientific notation.
Oh,
Remember, it's one significant digit. That means some number 1 through 9, then the decimal. Okay. So that's our final answer for this when we divide. Okay. So that's our first example. Second one, number 2, is an application. So we're going to compare two types of cells. Your average animal cell of some type. So animal cell diameter. You're familiar with diameter? The distance across, usually a loosely circular object through the middle. Let's say it has a diameter of 9.97 times 10 to the negative third centimeters. Pretty small. And we're going to compare it to some sort of plant cell. And its diameter is 4.2 times 10 to the negative 4 centimeters. So the good thing is they're the same unit. So here's what we're going to find. Notice how I write this. How many times larger is the animal cell to the plant cell? Question mark. Leave your answer in standard form. Okay. Oh, I forgot. To the nearest tenth. To the nearest tenth. Okay. And it's asking how many times larger? With emphasis in the word times. How might that be different than if we were to ask how much larger? Here they're asking how many times larger, which is different from how much larger. How much larger is comparing just the actual sizes. Maybe. Here, it's how many times greater. What does that tell us to do? When we're asking how many times greater? Yes. It's dividing. It's comparing with a ratio. It's comparing with a ratio. So what we're actually being asked to do is look at the animal cell. Bless you. Animal cell size to the plant cell size. So we're dividing. Let's go ahead and do that. So we have 9.97 times 10 to the negative 3 compared to or divided by 4.2 times 10 to the negative 4. So how many of these plant cells go into the size of a animal cell? All right, let's divide. Okay, so let's take our coefficients, divide those. 9.97 divided by 4.2. Look at that. 2.37. Yeah. Now, keep in mind, we have to round this at the end. So we've got to keep some digits. Let's see. Let's go up to the thousandths, maybe. That 3 in the thousandths. Are we going to If we're rounding it,
2.374.
yeah, maybe change that to a 4. 2.374. Let's write that down. 2.374. And I can already tell that since that's in scientific notation, we should be okay. We won't have to push a decimal at this point. But what we do have to do is this part. What's our exponent on the power of 10 going to be? Negative 3
It's gonna be positive 1.
plus negative 4. Oh, I'm sorry, minus negative 4. Minus negative 4. And it is going to be, yeah. Switch this to plus, plus. And that's positive 1. Okay. Times 10 to the 1. So 2.37374 times 10 to the 1. Okay. This is in scientific notation, though. They also want leave your answer in standard form. So let's convert this. How do we undo the scientific notation stuff we did?
You add a 0. You move the
Yeah, we want to move it over once so that this becomes 23.74. But now we want to see, I didn't know if we had to adjust the decimal, so that's why I had 3 decimal places. But now we just want to leave this in to the nearest tenth, which is where 7 is. So it becomes 23.7. And how do we end this? 23.7 what?
Times 1.
Times larger. Wow. So imagine you're whatever size you are, and there's someone else who's 24 times larger than you. That's the comparison of a animal cell, your average animal cell, to a plant cell. It's about 24 times bigger. So we will be handling a few questions like this. Yes.
Okay, so it's 27 larger. How many times compared to us? How big would that be?
Well, imagine your size and imagine there's 23 people like kind of built around you. There's a person here, a person here, a person there, all around until you have 24 people. Yeah, that's, well, I guess counting you there would be 23 more people. Counting you would make 24.
Yeah, it
So.
would be around 120 people. Or
Yeah.
120. Yeah, 120 feet tall.
Yeah, if they're stacked up, yeah.
If you're 5 feet exactly.
Very much so. So in the micro world, things kind of explode on us. All right. So today we got a Delta Math. We are going to have a few where we're going to divide and a few application questions where we have to divide. Okay? Let's get to it. I have to text Miss Green what she needed. Sorry. I didn't even know she walked in.